So, well, hi there. Hi, Clem. Sorry for the really late update. I've been busy and had other things to do. I wanted to update us and wanted to answer to you. First of all, thanks for subscribing, Dr. Cassette. Danke fürs Abonnieren, Dr. Kassette. Ich schaue auch oft auf deinen Kanal. Ich bin über deine Projekte informiert. Danke fürs Abo. So, Clem, I've seen your video, and first of all, thanks that you rebuilt pretty much of what I said, and thanks that you mentioned me. And there was a comment somewhere. Someone saying, this looks like a direct conversion receiver to me, not a super hit. There's no down conversion. Okay, well, it sounds by the audio. There we go, Clem. So here is your superhead receiver. It's working as it should. You can hear the station.
A lot more stations now.
This is still superhead. But there we go. That's these sounds. Now something is oscillating in your circuit. So this is because the person here, the ham and shortwave radio guy, wrote that this looks like the direct conversion receiver, because at this point it really sounds like a direct conversion receiver. And I guess what happens is, when I go to the schematic, is that your values here 2.2K, 2.2K, these are too small. You have, okay, your circuit is working, but the problem is that you have a really high level here. I mean, with this resistors, you make it a couple of nanowatts or even microwatts, I think rather microwatts, or even up to 1 milliwatt or so of RF power, which is too much. And also this resistor here, you change this one to 100K and you leave this one to 1.5 mega ohms. Well, the problem is, if you have 100K here, you have only very less or very low current on the collector. And with a 1.5 mega ohm, what happens is that you have a very strong signal on base, and this will pretty much shorten out more or less. So if you add 100K here, you want at least have 10 mega ohms here. This will get better. This capacitor is a little bit too big. It will cost you selectivity. You could increase the values of these capacitors. Also here, this 1 nanofarad. Oh, I see, you changed it to 10 nanofarads. Okay, everything's fine. But yeah, so I guess what happens is that this diode here, you have a very strong signal and it's transmitting, and it goes back into the wiring of either your antenna or your local oscillator, which is fed in there, and also of course it's putting out a little bit too much power in my opinion. And then you get the sound that you just heard. Sounds like a direct conversion receiver. What is a direct conversion receiver? To explain that to you, well, it's basically also a superhead receiver, but you do it, for example, you have your signal on 6 megahertz, and then you tune your oscillator to 5.999 megahertz, and then a different frequency would be 1 kilohertz. And you can hear 1 kilohertz. It means that you don't need a diode for demodulation. You can connect on the output of the mixer stage, you can connect your headphone there. And direct conversion receivers are used in amateur radio. You can use CW, which is Morse code. Then you can hear the beeping noises. And also you can use this type of receivers for SSB, single sideband stuff. So I don't want to go into detail too much because that's quite complex. Anyway, just what I wanted to say is, first of all, thanks for rebuilding my ideas and rebuilding my stuff. As you can see on your build, it does work fine, but you could improve the selectivity by decreasing the value of this capacitor and also make this coil tunable or add a tuning capacitor. And also you somehow must get rid of the problem with this system starting to oscillate at a specific frequency. I'm not sure which frequency, but I could imagine that if you're going down with the frequency, it starts oscillating, because what could happen is that somehow the harmonics are being picked up by the input coil and everything starts oscillating. So overall your superhead is working just fine, but on some frequencies it still needs some tweaking and tuning. And for the ham and shortwave radio person, we have some down conversion here. Here we have Clem is mixing the amplified input signal, but what I can't really get is, Clem, why do you add the local oscillator here? I mean, this makes the first stage completely useless. Maybe it's an error in your drawing or your schematic. The local oscillator should go in there. Maybe you have made it and you just have a wrong drawing or something. But anyway, the down conversion happens on the first stage. You get your input signal, which is, for example, the shortwave station you want to hear, and Clem adds probably the local oscillator there. And this stage then works as a mixer. We have some filtering here with a very sensitive or very narrow banded filter. And we have another filtering here. So there is not really a way that the input signal can pass through these stages, because for 6 MHz or 6 MC, this will be pretty much like a short circuit as this is. But we have the downconverted signal, which is 470 kHz or something. And this, for this frequency, this just works fine. You tried the 100, was it 100 microhenry or 220 microhenry coil clamp at the beginning, and it didn't work. Why didn't it work? Well, in theory, it might work. Because, as you know, if the frequency gets higher, the blind resistance or the inner resistance of the coil gets also higher. But the problem is, if you add 220 microhenry here, you do not only have the parasitic capacitance from the windings, you also have this capacitor and the capacitor from base to emitter, which is then in parallel to your circuit. And for example, you want to tune in 6 or 7 MHz, but your actual resonant frequency of the coil is somewhere down on, let's say, 1.4 and 1.5 MHz. So you have your input stage tuned to 1.4 and 1.5 MHz, and you want to receive 6 MHz. Doesn't work. So, once again, thanks for rebuilding this. All others, thanks for subscribing. I'm really happy about that. And I've just seen that you have made a power inverter video clamp, but I just started this PC, saw that you made a new video, and no, I didn't watch it yet. I'm sure it's good and it's awesome, but I just wanted to comment this. And I'm not wanting to tell you how to make a power inverter, because you sure know. Okay, here's some other stuff. Here I've built a receiver again. I'm using a 1 meter long wire antenna and a 2 meter long ground wire. And this is just some stuff that I want to show you. Therefore I will turn off my computer, because it's making some interference on shortwave on a short distance. This is just a superhead receiver, as you know it, with some slight changes, because here I'm using a regenerative receiver instead of the diode. And this gives me a really sensitive receiver. Here I can align the gain from the regenerative receiver, and therewith I can align the sensitivity and the audio quality, because it's like as if I would align the filter bandwidth. If I go back with the gain, I will get more filter bandwidth, which allows me to get a better audio signal or better audio quality. But therefore, the selectivity is bad. For example, I have stations, they are 25 kHz separated from each other. When I turn back the sensitivity, they are mixing up with each other. If I get the sensitivity all up before it starts oscillating, I can very, very exactly separate them from each other. But therefore, of course, the audio quality goes down a little bit. And also the circuit definitely is far away from being optimized, so the audio quality isn't that good. I just threw it together to show you the basics. And I also want to show you a schematic, because I want you, or if you want it, that you can do some own experiments and not just rebuild it like, oh, he's showing me the schematic, I have to rebuild that. No, I'm just giving you hints what you can do, and so far and so on. So anyway, there should be a station tuned. Yep, there is a station tuned. That's a German station. It's Sunday again, and on 60-70 kHz for a few minutes they're still running a special program from the amateur radio operators. As I said, they're renting a transmitter and making their own program, and this is just some waffeling from this radio station. What I want to show you first is this BF245 transistor. It's a JFET, and I'm using this as input amplifier. And the special thing that you can do with these JFETs is, if you add a voltage on gate, you can align the gain of the circuit. So if I add a rather positive voltage, the gain will decrease. And if I pull the gate via a resistor, in this case 10 megaohms, to ground, I will increase the gain. What have I done? I've added a 10 megaohm resistor, and just for example, I've added a potentiometer which is between plus and minus. So I can vary the voltage that goes to gate of this transistor. Now I'll turn up the volume. I try to align the station a little bit better. It's hard. Okay, this is another station. This is KBC Radio on 6095. And now what I'll do, so now this is the resistor, the 10 megaohm resistor pulled to ground. So it's pulled to ground. And now I'll pull it rather to plus. And first I'll try to align the station again, which is not that easy. So the 1 meter wire antenna seems to be a little bit short, but anyway I can hear it. I think you can hear it in the background. And now I'll add positive voltage to gate. And there we go. Negative voltage. positive. You can barely hear it because the reception ain't that good because of fading. Before I had these stations tuned in very strong and very loud. But anyway, as you can see, as soon as I turn to plus, it's completely disappearing. And if I turn the resistor to ground, it's coming in again. Of course, it's with fading. But this is one way you could build your HEC circuit. You can use one of these BF245, or if you can buy them, use BF545 SND. And by applying a voltage to gate, pulling gate to ground will increase the gain, pulling gate to plus will decrease the gain. You can build your circuit and then you can vary the voltage from the first input amplifier. One way to build your HEC. Just a short break. Another thing that I want to show you is the so-called fine-tune. So you can fine-tune your receiver. As I've said, I have seen it, I've made a video about it very long ago. This was pretty much my first video, where I showed you that you can take some variable capacitor diode like LED, and then you can connect it to the circuit and you have a fine-tune. As I say, go back in my videos and you will find this eventually. So now I've added this varicap, which is just a red LED, and it's inverted. That means I've connected the plus lead from the LED to ground and the minus lead from the LED over this potentiometer and a 100K resistor to this oscillator's tank circuit. And now something isn't working again. Oh, there we go. So that's a German station. So as you can see, I can tune it here. But the station is, now they're saying that the broadcast is over for today. So as you can hear, you can't understand it. I mean, they are saying we are end of broadcast for today. You can send us an email and so far and so on. But anyway, here you can tune in station radio DRSC. And here you can tune in this English station. Here's the English station. And here's the German. So they're saying with a broadcast power of 100 kilowatts from Vienna, if I got it right. But anyway, here's the regenerative receiver. Now we are in oscillation mode. I'll decrease the gain. And here we are again. As you can see, German station, English station. As you can see, there's some fading. Now the problem, there's some fading, it's annoying. But I think you get what I basically want to show you. So you can fine tune it. So it's hard to tune with this capacitor. It's hard to tune. This is the English station. And I just turn the potentiometer. Here's the German station. Here's the English station. So you can fine tune them. Because this is the varicap. And if I go back with the sensitivity here, it's getting more silent. And also, as you can see, it's just worse. So this is one way you could build your receiver, Clem. So you can add a regenerative receiver here. It's like mixing down to 1 MHz, and you have a fixed tuned regenerative receiver on 1 MHz. You have just one coil left in the IF stage, and then by adjusting the sensitivity of the regenerative receiver, you can go ahead and you can just adjust the quality of that. And it's just an idea. So BF245 for gain, automatic gain control. You can vary the voltage on the gate, and a regenerative receiver as demodulator. It's just one suggestion how you could make your superhead receiver. Okay, best regards, Stefan, and once again, Dr. Cassette, thanks for subscribing. Best regards to Dr. Cassette, Kühl de Clem, and of course all my other viewers.